Good day, everyone. I am Flordeliza Libiado from Ifugao State University, Tino Campus, Philippines. It's a privilege to be part of the 6th Penang International Multidisciplinary Conference 2025 and to share our research with you. Today, I am pleased to present our study titled Examining the Teaching Competencies of Elementary Teachers and their Relation to the Mathematics Performance of Elementary Students, which I co-authored with Mr. Peter Paul Canuto. Let's begin with the introduction. Mathematics has long been regarded as the queen and servant of the sciences. It serves as the backbone of science and technology, shaping the very progress of our society, as noted by Lee and Schoenfeld in 2019. While mathematics may appear abstract, as Ye and colleagues in the year 2019 describe, it holds a distinct position among other disciplines. Diedrich in the year 2019 even emphasizes that mathematics stands uniquely apart, possessing its own language, logic, and beauty. Indeed, mathematics can be considered a universal language. Its symbols, formulas, and principles remain the same across cultures and nations, unaffected by boundaries or perspectives, as Parker, Waller, and Flood in the year 2016 affirm. In the 21st century, education aims to develop learners who are scientific, critical, and analytical thinkers. Abre et al. In the year 2018 mentioned. Mathematics plays a vital role in achieving this goal. It cultivates reasoning, problem solving, and creativity, serving as a foundation for cognition, skills, and holistic development. Turning our focus to the Philippine context, the teaching and learning of mathematics in our country is designed not only to build computational proficiency, but also to help learners make sense of the world and contribute productively to society. However, it is quite alarming that the actual achievement of many Filipino students in mathematics does not seem to match their intellectual potential. As Suwan 2018 observed, while our learners generally possess average to above average intelligence, their performance levels often reflect only surface level understanding. In other words, many can recall and apply procedures, yet struggle with higher order thinking skills, the kind needed for reasoning, problem solving, and innovation. This concern is not new. The results of the Trends in International Mathematics and Science Study, or TIMSS, have consistently shown that the Philippines continues to lag behind other participating nations. In 2003, our country ranked 67th in mathematics and science, and by 2016 to 2017, that position had slipped even further to 79th. This is according to De La Cruz 2017. These results reflect a persistent challenge. Despite our learners' cognitive potential and our curriculum's strong intentions, there remains a significant gap between what students know and how deeply they can think and apply mathematical concepts. In discussing the literature and teaching competencies, it is important to recognize that these competencies refer to the knowledge, skills, and attributes that enable teachers to perform effectively in the classroom. They encompass several dimensions, from lesson preparedness and instructional effectiveness to classroom management and the ability to adapt to diverse learning needs. Some competencies are primarily grounded in knowledge, such as understanding pedagogy and subject matter, while others are more skill or performance based, reflecting how teachers apply what they know in actual teaching situations. Salvi in the year 2012 noted that the concept of teacher competencies has significantly expanded in recent years, particularly in response to ongoing educational reforms that demand teachers to be facilitators of learning rather than mere transmitters of knowledge. Furthermore, Nasip Bayeva in the year 2012 emphasized that these competencies are observable and measurable, allowing educators and administrators to assess a teacher's effectiveness through concrete indicators of performance. In essence, the literature underscores that teaching competence is not just about what a teacher knows, but know that knowledge is translated into practice through meaningful instruction, classroom interaction, and learner engagement. With the seemingly continuous low performance of students in mathematics and the capability of the teachers to influence the students, there is a further need to understand how the students' performances relate to the teachers' educational practices. This study is then developed to assess the teaching competencies and their relation to students' academic performance. Specifically, the study aims to answer the following. Number one, what are the teaching competencies employed by elementary school teachers in mathematics teaching? Number two, are there significant differences in the teaching competencies according to demographic factors of the elementary school teachers? Number three, what is the academic performance in mathematics of the elementary school students? And number four, is there an association between the teaching competencies and the students' mathematics performance? This study utilized a quantitative approach combining descriptive survey, inferential, and correlational designs. The descriptive survey allowed the exploration of teacher competencies and student mathematics performance, while inferential and correlational analysis examined group differences and relationships among variables. A validated and reliable questionnaire was used, and total enumeration ensured that every qualified respondent was included. Data gathering spanned 4 months, from June to September 2020, ensuring comprehensive coverage of the research context. The study involved 51 elementary school teachers from Tinok District, Tinok, Ifugao, Philippines. Specifically, it focused on grades 4 to 6 mathematics teachers employed in public elementary schools within the district. This selection was made to understand how students' academic performance in mathematics relates to teachers' educational practices within the researcher's own professional context. Although total enumeration was used, the small number of teacher participants corresponded to the relatively small population of elementary students, typically consisting of 1 or 2 class sections per grade level during school year 2019 to 2020. Table 1 shows the data on the distribution of the teacher respondents according to their demographic factors. In terms of gender, there are more female teachers compared to the male group. Regarding age, the largest population is 20 to 30 years old, then 41 to 50 years old, 31 to 40 years old, and the minor population is 51 to 60 years old. As for the highest earned degree, there are more teachers with a bachelor's degree compared to a master's degree. Lastly, teachers with 1 to 10 years of service have the largest population, followed by 11 to 20 years, 21 to 30 years, and 31 to 40 years of service. The instrument used in the study was a 15-item structured questionnaire originally developed by Balbalosa in 2010 for mathematics instruction. It was modified to fit the specific context of Tinok District. The revised version was pilot tested and yielded a Cronbach's alpha of 0.819, which reflects excellent reliability. The questionnaire had 2 sections. The first gathered demographic data such as gender, age, educational attainment, and years in service, while the second assessed teaching competencies across 4 areas: personality traits, teaching pedagogy, instructional materials utilization, and assessment of learning. This structure provided a clear basis for linking teacher competencies to student mathematics performance. For the data analysis, the 4-point Likert scale denoted the level of teaching competencies that reflected the teacher's performance. The statistical limits shown in Table 2 serves as the equivalent range of scores describing the results of the computed weight mean values. The weight means were interpreted as always A, sometimes as O, seldom as E, and never N practiced. On the other hand, the students' mathematics performances were determined through mean percentage scores, or the MPS. The MPS indicates the ratio between the number of correctly answered items in a test and the total number of items. Table 3 shows the distribution of scores divided into 4 equal percentages: superior, upper average, lower average, and poor, as referenced from DepEd in the year 2015. In analyzing the data, analysis of variance or ANOVA was used to test if there was a significant difference in the level of teaching competencies that affected the teacher's performance when grouped according to their demographic profiles. Then, the Pearson product moment correlation or the PPMC was employed to test the associations between the teacher's competencies and the student's MPS. For the results and discussions, Table 4 shows the assessment of learning with a mean of 3.62 as the most competency affecting the teaching performance in mathematics. Personality traits with a mean of 3.59 ranked second, while teaching pedagogy with a mean of 3.53 and IMC utilization with a mean of 3.28 are ranked third and fourth, respectively. It is also identified that teachers' competencies are described as always observed, regardless of rank. The identification of assessment of learning as the most competency that affected the teacher's performance in mathematics recognizes the positive effect of assessment on the quality of learning, according to Buhagiar and Murphy in the year 2008 and Chimaa in the year 2011. Through varied assessments, teachers could monitor students' progress according to Buhagiar and Murphy in the year 2008. Help the students to learn and aids in decision making to enhance instruction, as mentioned by Jimaa in the year 2001 and Pang in the year 2002. It suggests that the teachers developed scoring guides or rubrics with the students, allowing sufficient time for instruction. Feedback was used to communicate assessment results to the students, which helped to identify the students' strengths and weaknesses, according to Pang 2022. As gleaned in Table 5, the results show that there is no significant difference at p-value less than 0.05 level in the perceived effect of personality traits, teaching pedagogy, IMC utilization, and assessment of learning in the teacher's performance according to gender. Results points out that gender does not affect teaching competencies and effectiveness. This finding contrasts with the previous studies suggesting gender-based differences in teaching effectiveness, such as the work of Islahi and Nasrin in the year 2013, which identified one gender as being more effective than the other. Although no significant difference was found, we can still observe minor variances in the mean scores. Female teachers scored slightly higher in assessment of learning, indicating their strength in providing feedback and communication learning outcomes. Meanwhile, male teachers scored higher in personality traits, reflecting their inclination to motivate and engage students during classroom activities. Furthermore, both male and female teachers obtained similar mean scores in teaching pedagogy and instructional materials utilization. This similarly suggests that both groups possess a solid mastery of subject matter and employ practical, concrete examples in teaching mathematics effectively. In summary, the data imply that effective teaching transcends gender. It depends more on a professional competence, commitment, and the ability to facilitate meaningful learning experiences for students. When it comes to the teacher's age, results in Table 6 shows no significant difference, also at p-value less than 0.5 level, in the perceived effect of personality traits, teaching pedagogy, IMC utilization, and assessment of learning. It was indicated that age does not affect the teacher's perception of the competencies affecting their performance. This result aligns with the study of Waseka et al. In the year 2016, who reported that teachers' age does not have a significant effect on students' academic performance. However, it contrasts with the findings of Chang and Wang in the year 2014 and Odiembo and Simatwa in the year 2014, who found that age influences students' achievement. Although no significant difference was found, there are still slight variations among the age groups. Teachers aged 20 to 50 years old scored higher in assessment of learning, suggesting that they are more active in giving feedback, returning results to students, and using varied assessment tools. Meanwhile, teachers aged 51 to 60 years old scored higher in personality traits, implying that they tend to be more disciplined, consistent, and firm in implementing classroom rules. Interestingly, the results also show that the use of instructional materials was seldom observed across all age groups. However, this may imply a shift from the traditional to technology-based IMs. recognizing the potential of digital tools to enhance students' performance in mathematics, as noted by Lashley in the year 2017. Results in Table 7 reveals a significant difference at p-value less than 0.05 level in the effect of teaching pedagogy on teaching performance, considering the highest earned degree of the teachers. On the other hand, there is no significant difference in personality traits, IMC utilization, and assessment of learning. Regardless of educational attainment, the teachers share the same perception among the teaching competencies. However, this result contradicts several previous studies that found a positive correlation between teachers' highest educational attainment and students' academic performance in mathematics. For example, Dial in 2008, Horn and Zhang in 2017, Kowalskuk and Waledzia et al. In 2017, and Tucker and Faschel in 2013 concluded that teachers with higher degrees tend to produce better student outcomes. Likewise, this result does not support the NAEP 2016 report, which emphasized that students taught by teachers with master's degrees perform significantly better. Nonetheless, one important finding in this table is the significant difference observed in teaching pedagogy. This suggests that teachers with master's degrees are more competent in their pedagogical approaches. They are likely more organized in lesson delivery, updated with current trends, and capable of using varied instructional strategies and materials. They also tend to relate lessons more effectively to students' experiences and needs. Meanwhile, for personality traits, instructional materials, utilization, and assessment of learning, no significant difference were noted. This implies that these competencies are consistently demonstrated by teachers regardless of their degree level. As seen in Table 8, there is no significant difference at p-value less than 0.05 level in the perceived effect of personality traits, teaching pedagogy, IMC utilization, and assessment of learning in the performance of teachers when grouped according to years in service. Results reflect the non-significance among the teaching competencies according to years in service. This result contradicts previous studies that established a link between teaching experience and students' academic achievement. For instance, Avisati in 2018, Clotfelter et al. In 2007, and Rice in 2010 found that longer teaching experience generally leads to improved student performance. However, in this study, the teachers' competencies appear to remain consistently high regardless of how long they have been teaching. The data imply that all teachers, regardless of tenure, demonstrate strong competencies in classroom management, lesson delivery, and assessment practices. They are seen to maintain good relationships with the students, clearly communicate lesson objectives, and use practical and concrete examples in teaching. Moreover, they are actively engaging learners in the evaluation process by developing scoring guides or rubrics together with them. These results suggest that teaching excellence is not solely a product of years of experience, but rather the result of teachers' consistent commitment, reflective practice, and dedication to quality instruction. Table 9 summarizes the mathematics MPS of 231 students from grades 4, 5, and 6. The results show that all grade levels obtained a lower average MPS, thus yielding an overall mean of 45.80%, indicating a lower average level of mathematics performance. Based on the findings, the mathematics performance of students is lower average. This result reflects the beginning level performance of Filipino students in mathematics, as noted by Cordova and Tan in 2018 and De La Cruz in 2017. Likewise, it aligns with findings from national assessments and international studies, which consistently reveal that Filipino learners exhibit low proficiency and minimal mastery of fundamental mathematical concepts. These findings highlight the urgent need for targeted interventions to strengthen students' mathematical understanding and improve their performance. Addressing these learning gaps is essential to equip students with the numeracy skills necessary for higher learning and real-world problem solving. Lastly, the result of the PPMC shown in Table 10 indicates no significant association at p-value less than 0.05 level between the perceived level in all the teaching competencies, that is, personality traits, teaching pedagogy, IMC utilization, and assessment of learning that affects the teacher's performance and the mathematics performance of students. It can also be seen that correlational R values are negative, indicating inverse relationships between the teaching competencies and the student's mathematics performance. However, further analysis of the p-values indicates shows non-association between the two variables. As determined, there is the absence of a significant relationship between the teacher's competencies and the mathematics performance of students. This result contradicts previous studies asserting that teacher competencies play a crucial role in shaping student outcomes. For instance, Hill et al. In 2005 and Piopunik et al. In 2014 emphasized that teaching competencies are vital components of effective instruction, while Waseka et al. In 2016 found that these competencies significantly influence students' academic performance. However, in this study, the absence of a significant correlation suggests that factors beyond teacher competencies, such as students' learning attitudes, home support, or classroom resources, may also strongly influence academic performance. The teacher's role and capability are critical to motivating and honing the students' mathematical skills. This is why teaching competencies are essential and must reflect on what the teachers are expected to perform. The study unveiled that elementary school teachers always observed the teaching competencies during their mathematics instruction, whereby the assessment of student learning was identified as most observed. Results also indicated no significant differences in the teacher's perceived effect of the teaching competencies according to demographic factors. Moreover, it was determined that elementary school students performed lower average in mathematics. Further, the study disclosed that the teacher's competencies have no significant association with the student's mathematics performance. And these are the references in our study. Thank you so much for listening.